Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken here at University of Albany, and Joel, Seth's brother. We're here to hopefully show you how to approach studying for the SAT and also taking specific SAT questions. In terms of studying, always say the same thing. Go to Khan Academy. You could read this little thing here, who should take this course. If you're planning on taking the SAT starting in 2024 in the United States, then you should start practicing on Khan. On the digital side, if you want to see how to get here, watch our video. Watch the beginning of the video that we made on June 29th. So without any further ado, let's hit another question today that's sanctioned by the SAT. We are doing advanced algebra. We're only doing the advanced questions with the idea that if we go over the ideas that you could do the non-advanced questions. The lesser. Okay, now yesterday we did graphs and linear equations. Today we do solving. Yesterday we did graphs of linear equations. Yes. Today we're doing. No. Yesterday we did solving linear. Yes, that's right. Yesterday we did solving systems of linear equations. Today we'll start this one. We do one a day, and then we're just going to keep going and going and going. Okay. Systems of linear equation word problems. Okay, this is a classic algebra question. This is just probably the most important algebra question out there in linear algebra, first year, 9th grade algebra. 2 equations, 2 unknowns word problem. We've all seen these. Okay, everyone, ready? Please read it, try it yourself, come back, and we will do it together. Ruby can assemble 2 gift baskets by herself in 7 minutes. Emma can assemble 4 baskets herself in 15 minutes. Ruby begins assembling gift baskets at 1 p.m. and Emma begins assembling gift baskets at 1:15 p.m. If they continue to work at the above rates, at what time will they finish? Wow, this is a hard question. Wow. Emma. Remember, we don't do the problems ahead of time. Emma can assemble 4 gift baskets by herself in 15 minutes. So don't we add the rates, Seth? Don't we figure out what their combined rates are?
But there's also different starting times.
Right. Ruby begins assembling gift baskets in 1. When they say the 54th basket, can assemble 2 gift baskets, Emma.
Yeah.
Ruby begins assembling.
So at what time do they finish assembling 54 baskets?
But we don't know yet how many each one assembles.
No, we don't.
That's the problem.
That's right, yeah. But I guess the point is, when only one of them is working, there's a certain rate.
Yeah. Right.
And let's see, who begins first? Ruby begins first. PM. So Ruby's rate is 2 out of 7. 2 gift baskets per 7 minutes.
Let's be very
That's her
neat.
Rate.
Let's be very neat today.
And Emma's rate is a little bit is how much? Is she slower? She takes 15 minutes for 4.
4 gift baskets in 15 minutes. Now, thankfully, it's 15 minutes, right? Which means that Emma begins 15 minutes later.
Yeah.
Wow. But that means Ruby did 2 gift baskets in 14 minutes. Look at how the answers are all so close to each other.
Oh, yeah. 2 minutes, 3 minutes.
So you're off by a minute, right? In 15 minutes later, then Ruby made 2 gift baskets.
Yeah.
So at 1:15, they have 2 gift baskets. Actually, they have not 2 gift baskets. It's 2 and 1 minute. 2 and 2/7 gift baskets. Because Ruby worked for an extra minute, right? Yeah. So at 1:15, they made 2 2/7 gift baskets.
Yeah.
Have you ever seen a problem like this? Are we missing something? Maybe it's supposed to be easier. When you see a problem like this on the SAT and it looks really hard, we're probably missing something.
I don't know. I would write a formula for the number of gift baskets assembled as a function of the time. Or maybe we should say what we should do is the number of minutes. The number of minutes after 1 p.m.
Yeah, right. The number of minutes after 1 p.m., right.
So you write down let M
plus 2 sevenths.
M equals the number of minutes after.
Oh, okay. After 1 p.m.
Yeah.
So that
after 1 p.m.
That is 2 sevenths times 15. That's because that's the first 15 minutes that Ruby worked by herself, right? And then the amount of time.
Ruby starts first, and she does 2 out of 7.
Yeah. Oh, so
okay. So then the 15. Okay, you changed the T. You made T the time after 1:15.
That's fine. Yeah. How do we do that?
So let's agree that T is the number of minutes after 1:15 that they've been working.
Yes. Okay. Let's change it because it makes the equation just a little easier.
Okay. Yeah, that makes sense.
That makes sense, right? Now, notice this is very important in approach. The let statement in an algebra question is the most important thing. Without the really understanding the let statement, you can't do the problem. I changed the let statement in the middle. That's okay. Just make sure you change it. You know what you do.
Yeah, okay.
Now we add the rates, right? 2 sevenths plus 4 fifteenths. And this equals 54. Right? That's the equation we need to solve, right?
Wait, 2 sevenths of a minute. Okay, plus 5. Yeah, okay.
Wait, now, the very interesting problem here, which you wouldn't necessarily see on the SAT, they want us to use a system of linear equations. We're not doing a systems of linear equations, are we?
Yeah. Just one linear equation.
I know what they want to do. They want to set this up as a table question, which we'll do later. We'll do it later. We'll do the table. We'll do it through a table later. Seth and I never were grown. We never grew up using tables.
Table schmable.
Table schmable, right? But that's the modern way.
Right.
That's a very
So anyway, you solve for T, and then make sure then convert T to the time of day.
Yeah, to the minute. No, minutes after 1:15.
Yeah, but the answer you have to give the answer. You have to convert that to an hour and minute.
That's right.
Time of day.
Right. That's right. So now we're not necessarily made this into a 2 equation 2 unknown. What do we do? Should we clear the fraction and multiply by 7 times 15 and just clear the fraction?
Oh.
And multiply by 105. Multiply both sides, everything by 105, and get those fractions out of there.
Oh.
Yeah, why don't we do that?
I suppose so.
Yeah, why not? So let's multiply with make a slightly bigger type. 105. 105. 105. Okay? Now, very, very neatly. 105 times 2 times 15 divided by 7 is 450. That's that. Plus, now, 105 divided by 7 is 15. 15 times 2 is 30. Right? Yeah. Plus, now, 105 divided by 15 is 7. 7 times 4 is 28. Now, we need a calculator for this. 5670. We subtract 450 from 5670. Okay. Right? So we get 5220. I could do this on a calculator. 58T. Look at me. Now we better pray that this is an even number. 58. 90 minutes. Right. Oh my God, 90 minutes. A nice number, 90 minutes.
Hold on a second.
8.
T times 30 plus 38T.
28T.
Oh, okay. So it's 58.
58.
You wrote 50. Okay, you corrected it.
Yeah. No, I knew what I was writing. I just wrote it messily. Okay, 90 minutes. So 90 minutes. Now you have to think about this. 90 minutes, 2:45, right?
So 90. That's 90 times 58 equals 5220.
Yeah.
All right.
Yeah. Now it's nice. I have to erase this, by the way, because I'm going over the question, which is not good. So it turns out that T is 90. Well, that's nice that we get a nice number. So we're probably right.
So 90 minutes after. So it's 90 minutes after 1:15.
90 minutes after 1:15, which is 2:45.
Yeah.
Yeah. That was a really good idea to write an equation, which is probably what you should do because this is a equation word problem. A word problem that's in a topic called equations. We didn't do two equations, two unknowns, though, did we?
Well, no.
No, we didn't.
So what?
Yeah, so what? Right, we don't have to do that.
The one unknown is the time after 1:15.
It's interesting. They don't have the related work problem that used to be on the New York State Regents in the 70s. No, that's the one where Ruby can make 7 baskets in 3 hours. Her friend could do 12 baskets in 6 hours. Together, how many working together? How long does it take them to make 10 baskets or something? That is a that's a different problem.
No, it's not. This is a similar problem. You add the total rate. What you do is you calculate from the fractions that they give you. They give you quantity and time.
Okay, then I
quantity divided by time is rate.
Okay, then let me
convert the two ratios of quantities and time to two rates. When the workers work together, the total rate is the sum of the rates.
Right.
You figure out the sum of the rates by adding the fractions, and then you use that to solve the problem.
Okay, let me re-say the problem. This is the classic related.
So here we did the same thing, except that there was an extra term. The 2/7 of a basket times 15.
Right.
Is added to the total.
Yeah. No, so the one I was talking about is if someone can do a garden, if someone can mow a lawn in 3 hours.
Someone could make a gift basket.
No. Someone can mow a lawn in 3 hours, and then someone else can mow a lawn in 2 hours. Working together, how long does it take them to mow one lawn?
The same problem.
It is, but the equation is different because the unknown is in the denominator. The x is in the denominator. It has
how much time it takes.
Yeah. It's irrational.
You're interested in how the time it takes for them to do a whole load of 54 baskets. They're asking for time, just like the question you posed.
Yeah, I guess so. Yeah. Okay.
Well, is it so or isn't it?
I don't know. We'll do that problem.
They just don't guess.
No, we will do. We will do that problem. But first, let's talk about tables. So, maybe they're talking about systems of equations because they want you to use a table. Have you ever seen how to do a table? Have you ever seen how to do a table? Should we show a table? Should we show the table solution? Clear all drawings? Because this
you want to draw a table?
Yeah, I have to draw a table. Because
draw a table.
Okay, let's draw a table. Ready? A table. Table problems are very, very common. What we do is we draw a table. Okay? Now, on the table, we put rate times time is jobs. So, jobs or baskets baskets per minute times number of minutes equals number of baskets, right? Right? Now we put in the different characters in the story. We have Ruby, we have Emma, and we have both.
Yeah.
Okay? Now, what is Ruby's rate? Ruby's rate is 2 baskets in 7 minutes. Emma's rate is 4 baskets in 15 minutes. The unknown are the number of minutes. So maybe we should put in, now what do you want the T be? Should we have T be the same thing? T is time after 1:15. So that would be time after 1:15. Time after 1:15. Together they want to make 54 baskets. The rates are added. The time is the same. But now the problem is Ruby. The number of baskets that Ruby made is really 2/7 times 15 plus 2/7 T. This is 4/15 T. And then you add these up, and then you get the same equation we had before. Right? Then you get literally the same equation. This 2/7. It's helpful to know that we knew the answer, right? Right?
Yeah, just keep talking.
Okay. Notice you get.
I just typed it in so that everyone could read it.
Right. The most important thing of a table are the top parts, the equation, the governing equation. There's a multiply. There's a big multiply sign here. We have to make sure you get it. Multiply. Rate times time is number of baskets.
Yeah.
So the table sort of organizes it a little bit better. When you use a table, every problem's done the same. There is this time offset though, and you could have done the problem, which we are not going to do, by letting T be the number of minutes past 1 p.m. We're not going to do that.
I could do it.
You want to do it?
I'll do it. I'll do it while you. I'll do it.
Okay, it's going to be a different equation.
Yeah. So let's use a different equation. Q R. Don't want to use R. I'll use S. It's 2/7 times. Okay, time. It's the time after 1 o'clock.
Time is after 1 p.m. So in red,
S.
I'll do the let statement for Seth.
Plus, what's the rate? 4 out of 15 times. And it's in minutes, right?
Yeah. Let S. Oh, that's good. Seth's using a different variable. Let S equal number of minutes after 1 p.m. So it's a different variable, has a different let statement. So notice there's a subtraction there, which is always harder to understand and write and to deal with. We only have addition signs, which conceptually is, I think, easier to understand. Seth had to subtract something. Does that look right? Plus 4/15 time. Right, so in other words, the 4/15 person works 15 minutes less. Yes, the 4/15 person works 4/15 minutes. Works 15 minutes less. Okay, that's not too bad. Okay, so should we check the answer?
Uh oh. Let me change this. S.
All right, yes, good idea. Okay, so I think we're done with this problem. But what we could do is after we'll look at the answer, we'll see how they did it. It'll be interesting to see how they did it with two equations, two unknowns, isn't it? Can you in your wildest imagination understand? Would the two equations and two unknowns be Ruby's time and Emma's time, and then you add them together? I don't. What do you? How do you think they would? How do you think they? Let's take a guess. How do you think they would set this up as a two equation?
I have no idea what they do.
It's possible they do the time. It's possible they use the time, like one person's time, Emma's time, and Ruby's time, and then I don't know. We'll find out.
Well, it could be the number of baskets that each one does.
Yeah, it could be the number of baskets that each one does. Yeah. Right. Yeah. Oh, right. Where R plus AE adds up to 45. Right. Well, we'll find
54. It adds up to 54.
There we go. You see, there's the dyslexia kicking here.
But that's silly because the time is still unknown.
I know. So this will be really interesting to see how they do it.
So it's let's see how they do it.
Let's see how they do it. We are perplexed, which is good to be for short time.
Well, a single equation is a system.
Yes, of course. Yes. Okay. Now notice that they don't give us the thing. They say keep up the persistence. They don't say, could you show us how to do it? So now what we'll do is we'll just keep banging.
This is show a hint.
Yeah, I know, but we'll just keep banging at this. We'll just keep showing 8 steps. Whoa.
Oh, come on.
8 steps. Whoa.
Come on.
Wow. So let's just get all the 8 steps on here. Oh my God. Look at this.
They made it too complicated.
They certainly did. Normally, I always think that the table is a more complicated way of doing it as opposed to writing systems of equations. But in this case, it looks like the table and doing it. The table was essentially what we did. Okay, let's start by defining some variables. Very good idea. Very, very good idea. R be the number of minutes Ruby spends. E. Okay, so they're off by 15. Oh, wait, no, are they? R and E. Okay, got it. So they're doing time as the variables. Now, this is very important. This is the governing equation. This is so important. They had to use the governing equation like we did. In the table, the governing equation, rate times time is jobs. Okay, so now we got the job, the rates. That's good. Now we're interested in when they sell 54 baskets. Fine. This plus this is 54. Very good. And then we know that this was off. Okay, fine. So then it turns out that the time offset was 15. That's the two equations, two unknowns, and then they essentially did what we did, right? Over here in step 6, it's essentially what we wrote. In fact, that is exactly what I wrote. That is exactly what I wrote. They did not clear the. Did they clear the fraction by multiplying by 105? What did they do?
Yeah.
Not really. Not really.
They kept 105 in the denominator, and then they solved for E.
No. They converted 2/7 into 105ths. Yeah. They used common denominator as opposed to just multiplying the whole stupid thing by 105.
Same.
Well, not really the same.
Same idea.
Yeah. So they did two equations, two unknowns. What we did is too bad we can't go back. We probably can go back. Can we go back? Yeah, we can go back. I don't know if we can really go back. I'm trying to go back. No, can't go back. When I wrote the equation, we essentially did the same thing. Okay, today's Throwback Thursday, but do you want to do that related rate problem that we mentioned? Because Seth wanted to say, well, let's not be vague about it. Uh, should we do it?
Well, do you have the problem? Is you have it ready?
Well, we can make it up. This is our Throwback Thursday question, which we'll talk about in a second. Hey, well, come on, Zapeward. How come you're not? Come on. There's a Throwback Thursday question. So, okay, let's annotate. Let's see. You can make these things up into they're a dime. They're a dime. They're very. Oh. Okay, hold on. I'm just trying to annotate. Okay, fine. Yeah, so this one, right? Billy does one lawn in, I don't know, 2 hours. James does one lawn in 3 hours. Working together, how long does it take them to mow one lawn? So, I mean, you can do the table. Lawn per hour times time, hours, number of lawns. Billy, James, and together. Together they make one lawn, right? Billy is 1/2. James is 1/3. Time, 1/2 t plus 1/3 t. Oh, yeah, so the same thing, right? 1/2 t plus 1/3 t is 1.
Yes.
Yeah. Okay.
So it's the reciprocal of the sum of the reciprocals.
Yeah. But sometimes they ask you what someone's rate is. I know sometimes there's an x in the denominator. So that would be the
well, any of these things, any of the quantities, they might give a problem where any of the quantities is unknown and the combined quantity is given. And so it's because it's posed as an algebra question to set up the formula for the value that's given. The unknown quantity is somewhere in the formula. The formula is in an equation, and you solve for the unknown quantity.
Yeah. So there were really the problem we just did. There really were a lot of approaches to set up that
the number of lawns Billy could do in an hour, that might be unknown. The time it takes for him to do one lawn might be an unknown.
Right.
The number of lawns James does in 3 hours, that might be unknown.
Right.
Or the number of hours it takes James to do one lawn is unknown.
Right.
4 unknowns for the two rates.
Yeah. Okay, so I think we did that problem enough. There are different ways to do it. You could have done 2 equations, 2 unknowns. You could have set it up as a table. In any case, it was a pretty hard question compared to other SAT questions that we've been dealing with. And if they say it's on Khan, it could be on the digital SAT. So you should know how to do that problem. Okay, so ready to do Throwback Thursday? Do we go back to a test? This question here, this test, I believe, is from as late as the teens, 2010, 2012, 2013, 2014. So it's fairly recent in the scheme of things, but it does have a different feel to it compared to the post-2016 SAT. And it doesn't look like they're going back to these types of equations. Again, what is this show-all thing? What is this? Okay. Seth, can you annotate? Oops, I hit stop share. That was bad.
Uh-oh.
Yeah, I know. The world's going to blow up. Okay, here we go. Okay, Seth, can you annotate? Okay, anyway, Throwback Thursday. Here we are. We go back to a test from before 2016 when the tests were actually called reasoning tests. Hello. Reasoning tests. So this question has a whole different feel to it. So please try it, pause it, come back, and we'll give it a shot. When a certain odd number is divided by 5, the remainder is 1. Which digit must be in the units place of this odd number? Well, number theory type thing, right? Number theory is not really a topic on the SAT these days. Oh, Seth's an expert. Seth has a PhD in math, so he knows something about number theory. Okay, what's his plan here? Which digit must be in? Oh, wow, I don't know what Seth's doing. Certain numbers, odd numbers divided by 5, the remainder is 1. Which digit must be in the units place? It's either a 1 or a 6.
Now, let's count by 5.
A 1 or a 6? I would say 1 or 6, so that would be 1. But you could use an example, right? An odd number is divided by 5, so that would be an odd number.
When you count by 5s, you get all the integers that are divisible by 5. Right? You start with 0, get 5, 10. Each time you go to a new number, the last digit changes from either a 5 to a 0 or a 0 to a 5.
Right.
So you could tell whether the remainder is 0 by whether the last digit is a 5 or a 0.
Of course.
Now, if the last digit however much more than the last digit is above 5 or 0 is the remainder when you divide by 5.
Right.
Now the next digit after 5 is 6.
Yeah.
So if you divide a number that ends in a 6 by 5, the remainder is 1.
Ooh, but it's not odd.
But this problem is about odd numbers.
Right.
What the remainder is when you divide it by 5. So the only other number that has a remainder of 1 and divided by 5 is a number whose last digit is 1.
Right. They should have put 6, isn't it? They should have.
They really should have, yes.
They should have put 6 as an answer.
Yeah. Well, they should have, yeah.
They should have put 6.
That would trick more people.
Yeah. They should have put 6 as an answer. So the answer is 1, right? Yeah.
Yeah. So you could figure out what the remainders are when you divide by 5 just from these digits. The remainder when it's 1, the last digit is 1, the remainder is 1.
Right.
When the last digit is 3, the remainder is 3.
Right.
What's the remainder when the last digit is 5?
0.
What's the remainder when the last digit is 7?
2.
And what's the remainder when the last digit is 9?
4.
Okay?
Yeah.
So there's only one of them where the last digit is, where the remainder is 1.
Yeah. So this question, even though it's very different from a more modern question,
if we follow the pattern, if we put a 6 here, the remainder would be 1. But 6 is divisible by 2. And of course, 10 is divisible by 2. So if you have any number, 3, 8, 5, 7, 4. Well, this big number here is this crazy 4-digit number times 10. And 10 is divisible by 2. So if you're wondering if this number is divisible by 2, you just have to worry. Everything that comes from here, 2 divides it. So you don't worry about it. And what's left over is the 4. And so to tell if the whole thing is divisible by 4, you look at the last digit.
I'm just doing a very
same thing. The same thing is true about 5, because 10 10 is divisible by 5. So you could tell. So it's 2 and 5 are single digit numbers, which you could tell the remainder simply by looking at the last digit when you're dealing with base 10 numbers in base 10.
I'm just these type of questions that are like number theory remainder questions. We didn't see too many of them. I just took a quick look at the first practice test on digital SAT because I have made a copy of it here, probably illegally, but I have it in my own use, right? I may just get a copy of it on my computer, and I just noted, I thought there was a question having to do with remainder. I swear there was, but maybe not. I thought there was, one of those questions where given a sequence, what's the 693rd number of the sequence? Yeah, so you should be ready for those. You have a sequence of 7, 8, 9, 4, 7, 2, and it repeats every 1, 2, 3, every 6 it repeats, right? What is the 932nd number in the sequence? It has to do with We're not going to do it now, but just make sure you can do that. I think that maybe...
We had a problem like that with colored beads.
Yeah, but it was on the old SAT, wasn't it? I don't know if it was on the new SAT, but something tells me I did one recently, and I thought it was on the new SAT. But anyway, do enough practice on the new SAT, and if this comes up, then make sure you know how to do it. But it's certainly not this number theory stuff. If you look at it, if we go back to this, we go back to this, like the topics. What do we have to do? We have to clear all. If you go back to the topics here, you don't really see these types of number theory questions, do you? They do problem solving and data analysis, advanced math, and geometry and trig. And in advanced math, you don't have number theory questions. So it looks like they probably dropped this topic. But,
Yeah.
Let's see, factoring, radicals, isolating quantities, quadratic equations, right? None of this stuff is number theory. So, yeah. Okay, so I think that's really it for today. Wow, we did a lot. 37 minutes. I don't know how many bodies survived all 37 minutes of this thing. But we did do those take questions that we did show how to do. And don't necessarily have to do with 2 equations, 2 unknowns. Okay, everyone. So have a great day. Hope to see you back tomorrow. Please like us, dislike us, give us comments on our YouTube videos, or email us at satmathquestionoftheday@gmail.com. Have a great day, everyone. Bye-bye.
Bye-bye.